Hopefully you liked our video from last week. We're going to talk to you a little bit about matter this week. Again, you've learned this before, but we're going to go over it, we're going to review it, and we have a few different activities. Very similar to last week, the format. You guys are doing really good with that. We really haven't had a lot of questions, so you must be understanding it and figuring it out. So we're going to just give you a little introduction about everything.
Hopefully you remember some of it or thinking about it when we were talking about sound as they kind of go together. So let's start with reviewing the different phases of matter. These are our phases. Okay, so we have a solid. What kind of particles does a solid have? Particles in a solid are going to be really tight packed together. They're going to be so tight, they're going to vibrate a little because they're always moving, but they have no space to go, so they're always vibrating. So the particles in the solid are going to look something like this.
And when you think of a solid, you think of all your solid objects. So like your desk, your pencil, anything that keeps its shape. Okay, so any solid object is going to have a definite shape and a definite volume. So if I have a block and I put it into a cup, it is not going to take the shape of the cup. It is going to stay that block shape. So that's what, when you hear it saying it has a definite shape and definite volume, it will not change shape.
The definite volume means it will always take up the exact same amount of space. If you take the block, put it in a cup, it's still the same size block. If you take the block and you put it in the freezer, it's still the same size block. If you take the block and you put it outside, it's still going to be the exact amount of space. It's not growing, it's not shrinking.
And when you even though your particles are so tightly packed, like Ms. Bertram said, your particles still are moving a little bit. So they are vibrating, but they are not spread apart. Okay, they're all nicely condensed and tight in that part, in that shape, but they are still vibrating a little bit.
It is like you guys when we line up for recess in the hallway. Right before the doors open, you guys are all kind of close together and you're really excited to go to recess, so you're kind of vibrating within that small space.
So and talking all the time in the hallway, which we know we're not supposed to do. But that's
a different point. So, solid, some things to remember. It has a definite shape and definite space. Let's move that so we can see it. What about a liquid? How is a liquid going to be different from a solid? Is a liquid always going to be the same shape?
No.
My coffee in my coffee cup going to be the exact coffee shape if I pour it onto my computer? Probably not. Okay. But would it be the same amount of coffee on my cup as it is on my computer? Yes. So that means a liquid has a definite space. It will take up the same amount of space, whether it's in the coffee cup, on your head, or on the floor. But it will not be the same shape.
So if I were to take my coffee in my cup, pour it into a bowl, it will take the shape of the bowl. Okay, because your liquids, they are liquid and movable. So whatever I pour it into, it will take that shape. Okay, remember how I said your solid will not, your liquid is different. It will take the shape of the container.
So if you remember when we were doing this in class, we said a solid is tightly packed and vibrating, and a liquid goes with the flow. It flows around. There's a little space between each particle so that they can kind of get around each other very gently. See, it'd be like, think of an example in real life, Miss Moyer. You said solids like you guys going out to recess. Liquid that would be more like two classes passing in the hallway. We're in a nice line, we're somewhat close together, but we flow right past each other because there's enough space to get around.
Yep.
Okay. Moving on to a gas. Gas, again, there's just there's so much of it. You're probably in a room right now full of gases that you don't even see. Like right now, I know that I must be in a room that has some oxygen because I am breathing. Most likely, there's also some carbon dioxide in the air that I am in because I am breathing out, and that's what comes out when you're breathing out. So my room is full of gas, and my room goes all the way into the living room. It goes all the way into the kitchen, and it flows all the way up the stairs. So the gas particles have the most space because they just go wherever they want to, wherever they can. They take and fill whatever container that they're in. So they take the shape of the container, which means that they don't have a definite shape because they're just going to be the shape of whatever they're in. And they also don't have a definite space. If I had some gas particles trapped in my water bottle right here, and I open the lid, that gas is going to go take the shape of the next container, which would be my house. So no definite shape, no definite space.
And this one would kind of be like you guys playing at recess. Okay, you're all spread out, you're all going in different directions, you're taking the shape of the space that you're in. Okay, and with gas particles, they are so spread apart, so they're really not bumping too much into each other, just kind of like you guys at recess. Sometimes you do, but
they bounce off one another. So a solid, tightly packed and vibrating, liquid goes with the flow, and a gas just keeps floating till it hits something and it bounces off in a different direction. So there are also some processes you have to know. We have to know what it's called when we make a solid into a liquid. You may be experiencing some of this right now if you've had one of those nice hot days. It's been kind of rare lately, but on a nice hot day, if you're feeling really, really warm, you want to cool off, you may go into your freezer and pull out a popsicle. If you don't eat that popsicle fast enough, it starts turning into a liquid. And the name of that process is what? Do we remember? It's called melting.
And this process, when you are going from a solid to a liquid, it requires heat. Okay, so if I'm outside in the summer and I'm eating my popsicle and it's hot out, that heat is going to make my solid popsicle melt into a liquid. Okay, so you got to remember that there are different processes depending on if it's heat being applied or if it's cold being applied.
Or another way to say cold being applied would be heat taken away.
Yeah, taken away.
Reducing
I never knew how to say that.
So, as we're moving this way on our chart, we're adding heat. As we move backwards, we're taking heat away.
There you go.
So, a solid to a liquid, we add heat and we call it melting. The next one is a liquid to a gas. Like after those big storms we've been having, there's been puddles on the ground. How do those puddles disappear and go away? That process is called evaporation.
And you can see if you've ever been outside during like right after a rainstorm and it is really warm, you can kind of see the gas going from the ground up to the sky. So it's adding heat to your liquid and it's going up. Another example would be if mom or dad or grandma's ever cooking in the kitchen and she's boiling something on the stove and there's a lid on it. If you take the lid off, you'll see little droplets and it'll kind of fog up. That is your liquid evaporating to a gas.
The other example is if you have a nice hot cup of coffee and there's steam coming off of it. That would also be evaporation.
Mine is not doing that because mine's cold coffee.
Yes, mine is not because it has cooled off coffee. But the next one is going back the other way. So if you have a gas and it's turning into a liquid, that would be like if you have a really, really cold cup of drink, like an iced tea or a Dr. Pepper or something outside, and you start seeing water droplets form on the edge of the bottle. That process is known as condensation. And condensation comes from the root word condense, which means it's coming together. So all those gas droplets, the molecules that are spread out, are coming together to be more tightly packed like a liquid.
And if you've ever heard someone say, like, my cup is sweating, or the heat's making my drink sweat or melt, or anything like that, it just means it's getting that liquid on the outside of their cup. So that would be your condensation. You've probably seen it before if you've been sitting outside with a drink, a cold drink on a warm day. The side of your cup will get condensation drops on it.
And again, to go from the gas to a liquid, you are reducing the heat. Reducing the heat.
Not less cold.
And the last one is one that we should all know pretty well. If we wanted to make us a popsicle for those really hot days, we would put a liquid into our freezer to turn it into a solid. So a lot of times we refer to this process as freezing, but there are other things besides freezing that can do the same thing. So we call this technically solidification. Solidification.
Yeah. And if you look at the word that she just typed out, the main word that sticks out to me is the word solid. So if I'm thinking in my head, I wonder what solidification means. Okay, it means making a solid. So like Ms. Bertram said, you do call it freezing, but your more technical term would be solidification. So if you are turning a liquid to a solid, you're making it solid, so you're solidifying it.
So to go from a tightly packed vibrating solid to a loose go with the flow liquid, it's melting. To go from a loose go with the flow liquid to a gas that's bouncing off of one another, it's going to be evaporation. To go from the gas back to the liquid, it's going to be condensation, which means it's coming together, condensing. And then to go from that liquid back to the solid, it has to solidify and become solid once more. Have the particles be pressed together again. And that's your quick review of matter.
You want to talk about the sound through it?
Yes, so if you're talking about sound like we did last week, we talked about which one sound goes through faster. So if you remember when we were talking about this in class, we played telephone. And the first time we played telephone, we were shoulder to shoulder, touching. And it took only a few seconds to get our sound all the way through the line. When we were a liquid and we were a little more spread out, it took a lot longer. And then when we were a gas and we were really spread out, it took a whole lot longer to get the sound through our line. So sound's going to travel a lot faster through solids because the particles are already so close together. Is that everything you can think of?
Yep, that sounds good.
Okay, let me move our faces so I can find the stop share button.
Okay. There are some videos that you are gonna have to look at. I'm sorry, I know you guys love my videos. They are really great. But I want you to really watch them and pay attention. And we'll talk a little bit more about it when we show you the slideshow. But they are really good videos. They're very informational. There's a lot of pictures. It goes over what Miss Bertram just taught you. And it kind of gives you real world examples, kind of like what we did as well. So there are only 2 videos that you need to watch. And I think together they're less than 10 minutes. So it won't take you very long. And they're very quick assessments.
So keep working hard. Reach out if you have questions. And
here, Zoe's going to say hi.
Zoe!
Say hi, Zozo.
Hi, Zoe.
Hi.
Hi,
Okay,
Zoe.
Hope you guys enjoy our video and you learned about matter and remember actually being taught.
And we'll see you again soon.
Yep.
Goodbye.
Bye, guys.